structure design concept, structure loading, load path, and much more coming up in this video. Keep watching. Hey guys, this is Jessica signing in from the YouTube channel Civil Engineer. Thank you for liking, sharing and subscribing to my channel. I highly appreciate your continued support. If you're new to the channel, I upload a video once a week. I provide guidance, assistance and help to civil engineers. If there's any topic relating to civil engineer construction you need help with, please consider the comment section below and I'm sure you can get in touch with me. Before I proceed with this video content, if you haven't subscribed to my channel, please consider subscribing, liking and share with others so others can benefit as well. Structure engineering, structure mechanics, a basic requirement for a civil engineer. This should be learned at the university level, but unfortunately I've faced graduate engineers and with little or no concept yet at the structure mechanics. So I thought it would benefit the students as well as the graduate engineers when they jump into the practice. Structure mechanics or design is a broad subject. I will split the subject into small videos clarifying an individual concept at short videos. The purpose of these videos are to clarify the concept and not jump into the specific design codes like British Standards, Eurocodes, ASTM, DIN, etc. I must add, it doesn't matter what structural design code you are using, the structure design universal truth remains the same, that the capacity or resistance of the structure must be greater than the actions or loading on the structure. In today's video, I'm going to talk about the structure loading and the load path, how the load transfer from top of the structure to the bottom through the slab, beams, columns, foundation and ultimately to the soil. So let's start. This presentation covers the basic civil and structure engineering terms, including the structure elements, structure load path and structure loadings. The structure elements. These are the basic elements of any structure. So by definition, the systematic way of connecting all these elements to withstand the applied load or action is called a structure. Now I will share a basic frame structure identifying all the structure elements. The frame structure itself comprises of beams and columns. In this picture, you can see it's a 3-bay by 1-bay by 3-story frame structure. The red highlighted shows the basic element of structure called slab. The slab can be classified as a 1-way or 2-way slab. So what is a 1-way and 2-way slab? So as the name suggests, the 1-way slab transfers the load to 1-way direction, and that is to the longest span. And 2-way slab transfers the load in 2 directions, and that is on both directions, longitudinal and transverse direction. Let's move on to the next structure elements, and that is the beam. The beam is the horizontal structure element which supports the slab on top. These are the longitudinal beam and these are the transverse beams. Columns. Column is the vertical structure element supporting the beams. You can see the shear wall here. I'll come to this in a minute. Foundations. Foundation is the lowest part of the structure supporting the whole structure on top. Shear wall. This is primarily used in the high-rise buildings to withstand the vertical as well as horizontal wind load. Lift shaft. Again, this is used in the high-rise buildings and can benefit the structural horizontal integrity against the wind load as well as the seismic load. So this concludes the structure element part of the presentation. Let's begin with the structure load path. I will consider the simplest 1-bay by 1-bay frame structure, identifying all the structure elements already defined. The slab loads are transferred to the beams as a UDL, uniformly distributed load. One thing you should have noticed here, the slab loads are transferred from all the edges, and it's classified as a two-way slab. This slide shows the beam loads. They are transferred to the column as an axial or point load. So the column is in axial compression, and finally the column loads are transferred to the foundation underneath as an axial or point load, which in turn is distributed to the soil underneath. Generally, the foundation load are distributed to the soil at 45 degrees. However, this depends on the soil properties. So this concludes the structural load part topic. So let's proceed with the third and final part of this presentation, which is the structural loading and actions. For the purpose of this presentation, I will consider the dead or permanent loads, live loads, and wind loads only. There are other loads that shall be considered depending on the geography of the structure, and this includes snow load and earthquake seismic load. So what is a dead or permanent load? As the name suggests, it is a permanent and remain constant over the time and life cycle of the structure. For example, weight of the structure elements, including slab, beam, column, etc. This also includes the permanent fixtures, including immovable cupboards, false ceilings, so on and so forth. The dead load can be calculated simply by multiplying the density with the volume. Live loads, variable loads, these are imposed loads and vary over the time. For example, occupancy of the structure. If it is a house, it will be different than an office building. Live loads are defined by design codes for the category of use, so whether it's a domestic, office, or industrial building. For a specific usage of structure, the live loads can be chosen from the design standards. Wind load. It is a variable load and is dependent on various factors, which are listed here. The design standards provides factors to be used to calculate the wind load or actions on a structure for the design purpose. So this concludes today's presentation, and the future videos will proceed with this video as a base. The videos that are lined up will cover structure element design, including beams, columns, foundation, etc. So please ensure you subscribe to the channel so you don't miss out on the future videos. Thank you very much for watching this video. If you liked the video, please consider subscribing to the channel so you don't miss out on the future videos. Please consider sharing with others to benefit others as well. Thank you.